Hello everybody, this presentation will be about flow sensors. My team includes Jarek, Evina, Dylan, Yueyong, Gideon, Rachel, and me, Jiaxing. In this presentation, we will discuss the types, mechanisms, characteristics, and applications of flow sensors. At the end, there will be some questions for you to answer as well.
So what are flow meters? Flow meters are devices used to measure the rate or volume of a moving fluid, either liquid or gas, in an open or closed conduit. It does so by either measuring the amount of fluid passing through the flow meter during a time period or by measuring the totalized amount of fluid that has passed through the flow meter. It is most useful when used to measure gases and liquids in a pipe. Flow meters ultimately improves the precision, accuracy, and resolution of fluid measurement. Some additional parts flow meters may have or require are transmitter that produce usable flow signal from the raw transducer signal, indicators that provide visual indication of fluid movement in the process, monitors that convert signal into viewable flow rate, switches that trigger an action based on preset flow set point, and regulators that maintain flow rate over a wide range of pressures. There are many different types of flow meters. To list a few, there are velocity, positive displacement, mass, closed pipe, open channel, differential pressure, target, and ultrasonic. In the following slides, we will be elaborating more on a few of these flow meters.
Differential pressure flow meters are the most commonly used flow meters. It works by making use of the Bernoulli's equation to measure the flow rate. The differential pressure flow meters provides constriction in the pipe, causing a pressure drop across the flow meter. The higher the flow, the higher the pressure drop. The differential pressure flow meters has two components, one that changes kinetic energy and the other to measure the differential pressure, which produces a signal that can be changed to get the desired flow rate. These are some of the different types of differential pressure flow sensor that are used in the industry. These are some of the applications that differential pressure flow sensor can be used for. It is more commonly used for oil and gas industry compared to the other industries that are shown here. Differential pressure flow sensors are still commonly used in the industry due to its long-standing user familiarity with the technology. There are some things that should be taken note about differential pressure flow sensor when it is being used. One of the things is that it should not be operated at a high viscosity, as a high Reynolds number will decrease the accuracy of the sensor. It is applicable to many different types of flows, such as dirty fluids or gases, but depending on what it is used to measure, it could compromise the accuracy.
Flow sensor is the velocity flow sensor, an instrument that can directly measure the fluid velocity. Because of this property, it is widely accepted and recognized. However, flow sensors like this are highly sensitive to process conditions, pipe geometry, and Reynolds number. One type of the velocity flow meter is the turbine and paddle wheel flow meter. Both meters work in the same way. As fluid flows past a turbine meter, the meter's vane will rotate. In both cases, the angular velocity is proportional to the velocity of the fluid. A magnetic pickup coil is mounted outside the pipe, as each magnetic blade passes the coil. The magnetic flux of the coil changes, causing a voltage pulse. The sensor measures the pulse rate, and from that, determines the flow rate. The flow sensor contains several features. It contains a magnetic pickup coil, turbine, and sensor. Turbine meters and paddle wheels are used in the same types of applications. One application is a petroleum plant in India that is using turbine meters for loading light hydrocarbon products into tankers and rail cars.
Positive displacement flow sensors are volumetric flow meters that measure the volume of liquid passing through the flow meter. It achieves this by trapping pockets of fluid between rotating components housed within a high-precision chamber. As the flow of fluid is causing the rotational velocity is directly proportional to the flow rate. Positive displacement flow meters do not need a power supply to operate, nor do they need upstream and downstream pipes runs to be installed. Some examples of positive displacement flow sensors are overgear flow meter, roots flow meter, rotating disc flow meter, and etc. As positive displacement flow meters are able to provide highly precise results and high turndown, these flow meters are ideal for viscous fluids. One out of the many applications is that it can be used in the chemical industries to accurately estimate the flow of viscous fluids, various chemicals, and hydrocarbons. In addition, it is also used to determine volumetric flow of petrochemicals, paints, and dyes. Another application of positive displacement flow meter is to measure fuel usage in diesel-powered boilers. Positive displacement flow meter can also be used for measurement of various chemicals for making batches in pharmaceutical laboratories.
Mass flow sensors measure the mass of fluid flowing through a particular point over unit time. The Coriolis flow meter is most commonly used due to its high accuracy and practicality, although it can fetch a hefty price tag. The liquid flows through a tube which is vibrated by an actuator. This acceleration causes the tube to twist and turn due to the inertia. The deformation is measured by the two sensors in the flow meter. The deformation of the tube is represented as sine waves in the graph. Since the degree of deformation of the tube is proportional to the mass flow rate of the liquid flowing through it, we can derive the mass flow rate by measuring the deformation of the tube and doing some calculations. In the picture below, the blue portion of the Coriolis flow meter helps us to interpret the deformation and do the calculations, thus giving us immediate values for mass flow rate and viscosity, etc. The Coriolis flow meter is most commonly used in the oil and gas industry. It is also approved for custody transfer, which is the transfer of substance from one party to another. This is important in businesses as the buyer would want to get the right amount of substance that he paid for, and the Coriolis flow meter is able to provide the accuracy for the transaction. As seen in the picture below, we can see the Coriolis flow meter in the LACT unit, which is used for custody transfer.
Closed pipe flows operates by obstructing the flow at the cross-sectional area, causing pressure drop. The pressure drop causes a change in fluid velocity. The principle is based on the Bernoulli equation and the continuity equation of fluid flow. By combining the equations, the relationship between flow rate and pressure drop can be found. The two main types of closed conduit flow meter is the differential pressure and variable area type. Differential pressure uses the principle of constant area variable pressure drop. Some of the examples are the orifice plate, venturi tube, and flow nozzle. Variable area type works with a constant pressure drop and constantly changing area. Rotometer is an example of it. Rotometer can only be used in vertical pipeline and its accuracy is lesser than other flow meters. However, rotometers are simple in construction, ready to install, and the flow rate can be directly seen on a calibrated scale without the help of any other device. Fluid flow upwards, and as the float moves up and down, resulting in the area of orifice changing, float will settle down where the pressure drop across the orifice outward thrust balanced with the gravity downwards force. Flow is calibrated with the flow rate. Closed pipe flow meters is used for fluid flowing in a closed conduit like sewer, kitchen pipeline, water pipeline, and fuel pipeline. Meters are placed near pipeline to get accurate results and is displayed on meters attached to the conduit.
Now we will talk about open channel flow sensors. Open channel flow meters perform flow measurement of liquids that are open to the atmosphere at some point in the flow measurement path. Regardless of which type of open channel flow measurement techniques are used, level measurement must be used in combination with velocity measurement, and a flow computer using the Manning equation of open channel flow to calculate the true flow rate of any wetted channel, for example, of pipes and streams. Open channel flow measurement is also difficult because of non-uniform channel dimensions and variations in velocities across the channel. Therefore, special flow sensors must be made. There are several types of open channel flow meters. The traditional methods use primary devices such as flumes or weirs. These consist of a primary device, transducer, and flow transmitter. The wetted primary device restricts the liquid flow stream. A transducer is mounted on or near the primary device to sense the level. The electronic flow transmitter uses the signal from the transducer to measure the level and determine the liquid flow. Now we'll be looking at the applications of open channel flow sensors. As the name suggests, application of open channel flow sensors are for open channels. Some of the applications include in water treatment plants, storm and sanitary systems, industrial waste plants, sewage treatment plants, as well as irrigation plants.
To end off our presentation, here is a summary of the different flow meters we have gone through in this PowerPoint presentation. To choose the flow meter, we base it on things such as the nature of the process fluid, the viscosity, sizing, and etc. There is no one-size-fits-all solution. The major factor is matching the right instrument to the particular application. Some flow meters work well when measuring different things. Poorly selected devices invariably will cause problems at an early date, as each flow meter has its own specific application and installation constraints, so it is wiser to use the application as the guide to choose the right flow meter rather than the technology required.